Again, apologies for my screen recorder running out of time. Let's pick back up. Left off saying this is now in a format where we can apply some knowledge about our inverse trig. We have -6 out front. This looks like our arcsecant setup. So remember, it's 1 over a, our a being the square root of 5, times arcsecant of the absolute value of u over a, square root of 5, plus c, and finally rewriting our stuff with x's instead of u's, we get -6 over root 5, which I'm not going to simplify. Arcsecant of absolute value of the square root of x over square root of 5 plus c. I'm guessing you all just saw that my pen is dying, so that's going to be fun. Let's see if we can get to the end before it dies. Here in the back, I don't want to say more straightforward, but definitely some different looking problems. I see trig in this next problem on the next page. I see cotangent, I see cosecant squared. I'm trying to think ahead. I know that the derivative of cotangent is cosecant squared. So my guess for this one is probably going to be u is going to equal cotangent of 3x. Other things you definitely could have tried, but since I'm seeing a cotangent and a cosecant squared, I bet this is the way to go. Taking the derivative, we get 3, I forgot negative. -3 cosecant squared of 3x dx. And we can replace our cosecant squared of 3x dx with -1/3 du. Oops, I almost forgot the 3 right there. So rewriting our integral, we're going to have integral. Let's bring the 5 out front. We have the -1/3, so -5/3, 1 over u du. And at this point, not too bad. -5/3 natural log of the absolute value of u plus c, giving us -5/3 natural log of cotangent of 3x plus c. So again, this problem was more about trying to think ahead. Can u substitution work like that? When I see this problem on the next one, again, I'm thinking, do I know the antiderivative off the top of my head? It doesn't look like I do. Can I use u substitution? Well, what makes me think u substitution might be good? I have a quadratic and a linear thing. The bottom certainly doesn't look like any inverse trig stuff, but we could always complete the square. So maybe it could be some inverse trig stuff, but completing the square looks like it wouldn't be a whole lot of fun. Let's start with u sub and see if that works. So u, let's call it our quadratic, our denominator, 2x squared minus 4x plus 1. So du would be 4x minus 4 dx. And even though these things don't look the same, what if I rewrote the top as 7 times x minus 1? Then you might say, okay. So we could think about this du being 4 times x minus 1 dx. So we have the thing that we're going to replace. So it looks like u sub is going to work out. We can take 1/4 du and replace our x minus 1 dx. So everything that was highlighted is going to become 1/4 du. I think I want to take that 7 out front, leaving us with 1 in the numerator and then u in the denominator. And again, we've done a bunch of these. That's 7/4 natural log of u plus c, so that is 7/4 natural log of the absolute value of 2x squared minus 4x plus 1. Don't forget, plus c. All right, we got one more to go. Last one. What are some things I'm thinking about right now? Well, I see a quadratic in the bottom. I see a linear thing on top. That's making me think u sub could be a possibility. But I am also noticing that this is x squared and this is 3 squared. So it also kind of looks like a setup for an arctangent answer. The problem with the arctangent thing is that we have this 5x on top, and we know for arctangent it's 1 over u squared plus a squared. du gives us answers. So that x on top is a little concerning if we're doing it that way. So let's try u sub. Equals 9x squared, so du equals 2x dx. But that introduces another problem. When we try to do u sub, it doesn't really take care of the 16. So what can we do at this point? We have to go back and think about things that we're allowed to do with algebra. If we take this integral, which with the 5x we can do u sub, with the 16 we can think about this in terms of some inverse trig stuff. Well, what if I just broke up this integral into two pieces? 5x over x squared plus 9 dx plus integral 16 over x squared plus 9 dx. Now, I can use both of those ideas. Isn't that so fun? We get to do twice the work. So this first one, u equals x squared plus 9 du equals 2x dx. I have an x dx that we can replace. So I need to move the 2 over to the other side, so we get 1/2 du equals x dx. So I'm going to rewrite this first integral as I'm going to have the half, the du. I'm going to bring the 5 out front, and we get 1 over u du plus. For this other integral, I think I'm going to move that 16 right there, and maybe I'll rewrite this as 1 over x squared plus 3 squared dx. Now at this point we should have an idea how to integrate both of these things. The first one is 5/2 natural log of u. We'll do the plus c at the very end. Plus 16. What is that the framework for? That's an arctangent answer. Remember, with arctangent we do 1 over a times arctangent of x over a, and we need a plus c at the end of that. Simplifying it, making it look just slightly better, we get 5/2 natural log of x squared plus 9 plus 16/3 arctangent of x over 3 plus c. And I will note, it's one very last final thing, that if you wrote your natural log without the absolute values this time, technically you're right, because x squared plus 9 is always positive. So I don't technically need the absolute values, but it's safer just to write the absolute values just in case. Sorry I wasn't able to be here today. Hopefully your homework goes okay. Tomorrow you have a review day for our end of chapter quest for the second half of chapter 5 the day following. So good luck. If you have questions, email me. I'm only a couple blocks away. Doesn't mean I can come by and help, but I probably could answer an email or two. So you got questions, let me know. Good luck with your homework.